today is 10.4 degrees and radians. So hopefully we get through this. You're gonna be just fine. It'll be great. But first we're gonna get through some bell work. Make sure we remember what in the world is going on with our word problems. So a ship is heading directly toward a cliff on the shoreline. So we have a ship heading directly to some cliff on the shoreline. It sights the top of the cliff at 30 degrees. So it's sighting here at 30 degrees. And then it's gonna travel 30 feet. So it traveled 30 feet. And then it sights the top of the cliff again at 45 degrees. We want to know what is the height of the cliff and see if we can figure it out. So in this one, we need to make sure there are two triangles that are given to us, so there should be two things we look for. So what we're gonna see here is on 45, this is a straight line. So we can take 180 minus 45 and see that this is 135 degrees, which allows us to find this angle here of 180 minus 135 minus 30, and we're gonna get 15. This helps us. This helps us use the law of sines, because now 15 and 30 are corresponding. And this can help us find this lovely piece of information here. The reason why we have to find this information here is this 15 is given in this triangle, not the triangle that has the height. So we have to make sure we do this. So we have sine of 15 over 30, which is gonna equal, so we have 30 and y. So sine of 30 over y. We cross multiply to see that y is going to equal 30 sine of 30, all divided by sine of 15. Plug that into your calculator and we're gonna see that y equals 57.96. And now that we know what y is, we have enough information to either do law of sines or one of our trig ratios. So let's do law of sines this time. So now that we have y, it corresponds with our 90 degree. So we can see that sine of 90 over our y is gonna have to equal sine of 45 to our x, since those are the ones that are corresponding. We're gonna cross multiply, and we're gonna see x is gonna equal 57.96 sine of 45 divided by sine of 90. You're gonna plug that into your calculator and you're gonna see x equals 40.98. And since this is what we're looking for of our cliff, feet. Okay. So when you create two triangles, you have to have two separate equations, because to find a missing piece of information in this small one allows us to get into our second. Okay? All right. Nice little review. But today, we're getting into degrees and radians. So what is a radian measure and how do I convert between degrees and radians? So we're looking more at the conversions and looking at the standard position of where angles are on circles. So we first need to look at a circle and determine some information that you're gonna have to know. So first off, this right here, I hope all of you remember, is your radius. So r equals radius. And what we're gonna look at is when we create a piece of your circle. We know that this has some degree. So this is our theta, our degree, or radian. We're gonna see that in just a minute. And we can also find s, where s is our arc length. Do we remember that from our circles? So this is, again, our basics: radius, arc length, and our degree of theta. So what we first need to understand is the standard position for an angle. And what that is it's a vertex at the origin. And remember, origin is at 0, 0 in a circle. You're gonna start from the positive and turn counterclockwise. For a positive angle. Okay, so again, standard position is just saying we start here at the origin, and when we move counterclockwise, we will determine our angle and our radians. Okay? So, in radians, the measure of an angle is based on the radius. So again, radians and radius. And what that means is our theta is S over R, remembering S is our arc length, and R is our radius. Okay? So whenever we're looking for radius, it's going to be arc length over radius.